those steps would be mathematical. And one of the more important was taken by Carl Friedrich Gauss, physicist, astronomer, and perhaps the best mathematician of all time. Gauss's mathematics would offer an elegant complement to Faraday's idea, and it would become law. In Faraday's terms, flux is represented by all the lines of force passing through any surface.
Gauss's law states that for any closed surface, the total flux is proportional to the net electric charge inside. If there's no net charge inside a surface, any positive flux outward through it must be balanced by an equal amount of inward or negative flux.
Gauss's law, which gives mathematical definition to Faraday's intuitive notion about the electric field, is actually an expression of the geometric meaning of any inverse squared law. In appropriate form, it applies not only to electric fields, but to gravitational and magnetic fields as well, and even to light flowing from the sun. In any event, Gauss's theoretical work, combined with Faraday's common sense, reveals a number of amazing facts about nature itself. For example, watch what happens inside a conductor where a lattice of positive ions is neutralized by mobile and constantly moving electrons.
An electric field passing through a conductor forces the electrons to flow until they pile up at the surface, repelling the motion of further electrons. But that means the electric field inside any conductor becomes equal to zero when electrostatic equilibrium is established. Therefore, a closed surface inside the conductor has no flux through it. So the net charge inside must be zero. But there can be charge at the surface, and no matter what's outside, the surface charge makes the field inside equal to zero.
And since all the action's at the surface, a metal box of any sort, even a flimsy screen-covered cage, can keep out an electric field. That fact can be demonstrated with this device, a gold leaf electroscope. Notice how it responds to the field of an electric charge. Notice, too, that even when an electroscope's inside the cage, it reacts in the same fashion. However, when the box is enclosed, an electric field can't enter to disturb the gold leaf. Any metal box can do it. And to this day, any metal box that does do it is called a Faraday cage. Of course,